We continue our study in Chapter 1 by moving to Section 1.5 now. Section 1.5 is about angles and their measure. In this section, we have two objectives. First one is we want to understand the measure of angles, which, maybe many of you remember from your high school classes. Should be a very quick refresher. And two, we want to use algebra and the angle addition postulate to solve applications and find angle measures. All right, let's start with some definitions. An angle consists of two different rays and a common endpoint. So if you look here, ignore what we're saying here, or some of the words here for now, but we have ray AC and we have ray AB, and they have a common endpoint, which is point A. All right, the rays are what's called the sides of the angle. So we have this side and this side. And the common endpoint here, point A, is called the vertex of the angle. All right, so point A is the vertex. The sides are rays AC and AB. Right? There's ways to name the angle. Right? We can call it, we use this, like it looks like a tilted greater than sign, but it's an angle sign. So we could call it angle A, for the vertex, angle 1. We call it angle CAB or angle BAC. Always, if we're going to use this notation, angle CAB or angle BAC, the vertex needs to be in the middle. Very important. Right. The interior of an angle consists of all points between the two sides of the angle. So this is the interior part. And the exterior of the angle contains all points that are not in the interior of the angle and are not on the angle. Right. So if they're on the angle, right, that's the angle themselves. Let's do an example. Identifying and naming angles. How many different angles are in the diagram here? Right. That's the first question. And then write two other ways to name angle 1. Now this is angle 1. All right, turns out there are three different angles in the diagram. There's angle 1, there's angle 2, and then there's this other angle, which is angle MPQ. So if you were to take away this ray N in the middle here, or excuse me, ray PN, you just have this angle MPQ. So there's actually three angles in that drawing. All right, another way to name angle 1 is you could call it angle MPN or angle NPN. Either one is totally fine. Now let's talk about a protractor. Right, the instrument shown is called a protractor. Right, it can be used to measure angles in units called degrees, and we denote degrees with this, what looks like a temperature sign. Right, for example, the measure of angle A here also the measure of angle A also denoted. So whenever you see this M, measure of angle A, right, that's what that M in front means. Well, if you follow this protractor here, we can see we start at 0, go up to 30. It's a 30-degree angle. Right. Suppose you have ray AB as shown here and point C on one side of AB. Every ray, for example, AC, can be paired 1-to-1 with the real number from 0 to 180. Right? The measure of angle CAB in degrees equals the absolute value of the difference between the real numbers on the protractor for AC and ray AB. So for example, ray AB here, right, is 0 degrees. Ray AC here is 125. So the difference between them two is 125 degrees. All right, acute angles. We want to classify angles. Acute angles are angles that measure less than 90 degrees. A right angle here is going to be equal to exactly 90 degrees. And for you to assume, or not even assume, for you to know that it's a right angle, it has to show this little box here. If it doesn't show this box here but looks like a right angle, you can't say it. It might be like 89 degrees. You don't know. An obtuse angle is something that is between 90 and 180 degrees. And a straight angle is just a flat horizontal line. That's 180 degrees. All right, so let's find angles, the measure of angle RQM, measure of angle RQS, and the measure of angle RQN. All right, then classify each angle as acute, right, obtuse, or straight. All right, so RQM, so here's RQM, bottom ray is 0, top ray is 45. That means that angle there is measured 45 degrees. Right, it's an acute angle. RQS here, you can tell right here that this angle here, from here to here, is a 90-degree angle. And then finally RQN, looks out to 165 degrees, minus 0 degrees, 165 degrees. That is an obtuse angle. All right, some definitions. Two angles that have the same measure are called congruent angles. In the last section, we learned about congruent lines. We can have the same thing with congruent angles. We call the symbol equal sign with the squiggly over it means congruent. So that's the congruent symbol. All right, if angles A and B are congruent, then that means the measure of angle A is equal to the measure of angle B. Also, if the measure of angle A is equal to the measure of angle B, then angles A and B are congruent angles. All right, we mark congruent angles with exactly the same number of arcs as shown in the figures below. So just like how we had tick marks in the last section, single mark here and here means these two are equivalent. Double marks here and here means these two angles are equivalent. All right, use the figures to answer each question. First, if angle of measure C is 45 degrees, what's the measure of angle D? And then finally, if the measure of angle 3 in the second figure there is 113 degrees, find the measure of angle 4. Well, since they have the same tick marks, if angle C is 45 degrees, then that means angle D must also be 45 degrees. And it's the same thing with the other one. If angle C is equal to 113 degrees, angle 3 is equal to 113 degrees, then angle 4 must be 113 degrees. All right, another postulate. Postulate 1.5-2. This is the angle addition postulate. If P is in the interior of angle ABC, right? So we have P, we have this point. Then the measure of angle ABP and the measure of angle PBC is equal to the measure of ABC. So what that means is if you have two interior angles, you can sum them to get the measure of that full angle on the outside. All right, let's do an example about dividing a pizza application. A circular pizza can easily be cut into 8 slices because of the case of using a straight knife, as shown below. First cut is 2 slices, second cut is 4 slices, third cut is 6 slices, and the fourth cut gives us a final cut of 8 equal slices. So let's find the angle measure of a slice cut into 8 equal slices as shown. Recall that a circle measures 360 degrees. Since each of the 8 slices has equal measure, we can divide by 8. And it looks like here that if a circular pizza is cut into 8 slices, then the angle measure of each slice is 45 degrees. All right, let's do another one. The angle, using the angle addition postulate. If angle DEG is a right angle, you can tell by this box here, right? Find the measure of angle DEF and the measure of angle FEG. All right, since, as I said, it's a right angle, that measures 90 degrees. And thus, using the angle addition postulate, the two interior angles, DEF and FEG, must sum to that total on the outside. So you can take the algebraic expression for each angle, add those together, and set them equal to 90. Combining like terms here, adding the 1 over, and finally dividing, we see that x is equal to 7. All right, remember that's not the final answer. You have to actually figure out what the angles are. All right, so use the value of x to find the angle measures. So the first one, DEF, is going to take that 7 and plug it in. And it looks like angle DEF is 26 degrees. And similarly on the other side, looking in 7, you see that angle FEG is 65